The reason why Voyager had this golden record of human sounds and music was because this is one of the first several spacecraft launched with a trajectory that would never return to the solar system at all. And so if it never returns, there's a chance it could be discovered by some alien civilization. And if they do discover it, let it be this emissary of who we are and what we stand for.
There's something out there. Humanity's most distant explorer, Voyager 1, has discovered an anomaly at the boundary of our solar system that is illogical and shouldn't be there. Could it be evidence that we are not alone, or is it just a glitch or some unidentified cosmic phenomenon? Pay close attention, since the recent discovery confirms the existence of an alien invasion. Voyager 1's main objective since its launch in the late 1970s was to investigate the outer planets before venturing into the uncharted territory beyond of our solar system. It swung by Saturn and returned stunning pictures of its rings after speeding past Jupiter and photographing storms on its surface that had never been seen before. Then it simply continued. By 2012, it had crossed the heliopause, the imperceptible line separating interstellar space from the influence of our sun. Already, this was a momentous occasion. However, it has now made a discovery so strange that even seasoned scientists are unsure of how to interpret it, even 40 years after launch. It's obvious before we get into this that what Voyager 1 recently discovered is much more startling than anyone anticipated, and you will be stunned by more discoveries than this one. The HELOP functions similarly to an unseen shield. The majority of the harmful cosmic rays and high-energy particles that speed through deep space are blocked by it. However, something unexpected is taking place at this barrier. Strange vibrations in the magnetic field that shouldn't be there are being detected by Voyager 1. Nobody anticipated how these waves would reverberate throughout space. The figures are not consistent. It was always thought by scientists that this area of space would be quiet, nearly motionless, and that the magnetic field would only slightly fluctuate. However, the instruments of Voyager 1 provide a different picture, one that raises the possibility that something or someone is resisting the very edge of our solar system. Why are these ripples occurring? The million-dollar question is that, according to some scientists, it might be a whole new form of energy that has never been observed before. An encounter in interstellar space between the solar wind and an unidentified factor. Some speculate that they might be signals from the Milky Way's deep regions, echoes of a massive, strong object in motion in the distant. However, the truly bizarre notions point to something even more disturbing. What if we are being approached by something? Are these signals evidence that forces beyond our knowledge are affecting our solar system? According to data from Voyager 1, there appears to be an unanticipated force pressing against our solar system's edge, as though the HELOP itself is being compressed. Might this be the result of surrounding stars' powerful stellar winds? Or is our solar system under pressure from a more powerful invisible force? According to others, these waves are caused by enormous energy currents that are moving through the galaxy, perhaps even from somewhere outside of the Milky Way. If accurate, this would completely change our understanding of how energy travels through space. Here's the real kicker though. These variations are not arbitrary. They follow a pattern, something recurring and constant. There is more than pandemonium going on out there. It is adhering to regulations that we do not yet fully comprehend. Is there any chance that the heliopause is functioning as an antenna, receiving signals from far away in the cosmos? What is sending them, if anything? Has an interplanetary discussion been taking place for billions of years, and we are only now beginning to listen in? Voyager 1 may be detecting a vast, unidentified energy system that spans the galaxy, according to some experts. This spacecraft might have discovered something genuinely revolutionary if that is the case. An invisible force that connects solar systems and may potentially govern the motion of planets and stars in outer space. This would imply that our solar system is a part of something much greater than we could have ever dreamed of, rather than merely existing in a vacuum. Data was not all that Voyager 1 was transmitting. It demonstrated that space is more dynamic than previously believed. Imagine that space is a complicated network of invisible forces that construct invisible bridges between stars, rather than a large, empty nothingness. In ways that are beyond our comprehension, these energy currents may be transmitting signals that connect entire solar systems. Everything we believe to be true about space is only a start if this is the case. It sounds like science fiction that the universe functions according to a secret system of interrelated energy flows. However, it might be the basis for everything. And if that's the case, the satellite's decades-long work may be more significant than we, music, ever realized. The satellite's longevity was never anticipated when it was launched in the late 1970s. It was constructed using technology that now seems appropriate for a museum, but it's still out there, continuing to move ahead and communicate with its home base. It has crossed the border between our solar system and the rest of the galaxy, traveling farther than anything that humanity have ever made, and it is returning data that has scientists baffled. How could such an old spacecraft be bringing to light things we didn't even know to search for? We are more than 14 billion kilometers away from the satellite. Nevertheless, it keeps whispering back, offering hints of what is beyond. Each bit of information it transmits is like a signal from the edge of existence, pointing to something more significant that we haven't yet discovered. We believed that we comprehended space. We believed we had a map of our solar system's boundaries. However, satellite discoveries continue to disprove our theories. At the outside of our solar system, we find unusual signals, unexplained forces, and interactions that go against our preconceived notions. Then comes the crucial query: what does the real world look like outside of our solar system? Could these energy currents, if they are genuine, indicate the presence of something more, something perceptive, something watching? For generations, we have pondered whether we are the only ones. And the question gets louder with each move the satellite makes. The barriers we believe to be unbreakable have already been broken. What if we simply haven't discovered out how to understand the clues that it has been giving back all along? Elon Musk has commented on this, describing the results of the satellite as a warning to humanity. We must create something better, quicker, and more intelligent if we hope to venture outside of our solar system and conduct a thorough exploration of the cosmos. SpaceX has advanced spaceflight. However, even the most sophisticated rockets available today are insignificant in comparison to what will be required to send people outside of the heliosphere. We may lose our opportunity if we don't take action right away, because space isn't empty, as the satellite is demonstrating. There are powers within it that we never anticipated. The possibility that distant sites in space could be connected by energy fields creates both intriguing and terrifying possibilities. What else could move down these channels if energy could? Is anyone else listening? Or are signals being sent along these currents by somebody out there? Every bit of knowledge the satellite provides ought to cause us to reconsider how we perceive the universe. These days, it's not only about planets and stars. It has to do with the unseen structure that connects everything. What if there is life outside of our solar system, not only in the ways that science fiction depicts them, but in ways that we haven't even thought of? Could forces at our solar system's periphery be related to something else if they are interacting with interstellar space? What if life is already present, but we aren't able to identify it because it doesn't match our limited expectations? Life has always been perceived as having to appear a specific way. However, the cosmos doesn't operate according to our laws. We're only now beginning to realize that it does what it wants. The satellite is no longer merely a spacecraft. It serves as a reminder of our ignorance. It has sent signals back from places that no human will ever visit in our lifetimes, going where no one else has. However, it might not be by itself. Every odd signal and every inexplicable data spike can be a mystery just waiting to be solved. Perhaps it's a cosmic whisper from something far older and more developed than ourselves. Whether the universe is full of unknowns is not the question. Are we prepared to confront them then? What might be the purpose of invisible bridges in space? Were they made, or are they natural? Could some of the mysterious signals and sightings that scientists continue to discover be explained by these energy pathways? We must pay attention if the satellite is detecting signs of anything more significant, because the more we learn, the more it feels like we are only beginning to piece together the universe's true tale. Not to mention that the satellite is still in motion. It continues to transmit back whatever it can as it moves farther into interstellar space. Even though its technology is outdated by today's standards, it continues to function despite being alone in the icy emptiness. And that ought to make us question how and why. In spite of everything, how is this small, antiquated machine still functioning? Perhaps something outside is assisting it, or perhaps we simply don't know what forces music is passing through. This task isn't finished. That much is clear. The satellite never ceases to amaze us, even when we believe we have learned everything there is to know. Our preconceived notions about the solar system have already been altered by it, and now it is making us consider even more significant issues. What does the universe conceal? What lies on the other side of our comprehension? Although the satellite may not survive forever, the findings it makes will be remembered for many centuries. In the midst of an endless, uncharted galaxy, we inhabit a small planet, and despite all, the satellite continues to inform us that we have only just begun to explore. We will be stranded on this one small world forever, wondering what might have been if we don't keep moving forward and explore. The indications are coming in. There are clues. We just need to decide if we have the courage to follow them. History was made by this satellite. However, numerous other satellites have likewise altered our perceptions of space and the surrounding environment. We've been launching satellites continuously since people first made the decision to send objects into space. Everybody is contributing something fresh. Of course, everyone is aware of Voyager 1, but let's discuss the others, the ones who influenced our daily technological use and how we perceive the cosmos. Others are still out there circling the Earth doing their thing, while others made history and others failed. With Sputnik 1, the Soviet Union began the space race in the late 1950s. All it was a radio signal on a metal ball. However, it did prove one thing. It was feasible to launch objects into orbit. Other nations were forced to take space seriously after that little satellite caused a global panic. Next came Sputnik 2, which brought with it a stray dog from Moscow named Laika. Although she didn't return, her journey demonstrated the effects of space travel on living things. Although it was a depressing tale, it was significant. The United States retaliated in 1958 with Explorer 1 because it did not want to fall behind. This tiny device accomplished something enormous. It discovered the enormous regions of high-energy particles that are confined around Earth, known as the Van Allen radiation belts. Scientists' perspectives on space and how they planned upcoming flights to protect astronauts from radiation were altered by that discovery. NASA then adopted a different approach in 1960 by launching the first weather satellite, TIROS-1. This one sent images of clouds and storms from space, looking back at Earth rather than deep space. It marked the beginning of something significant, transforming weather forecasting from a well-informed guess into a legitimate scientific field. Echo 1, a massive metallic balloon, was launched in the same year. Although its only function was to bounce radio signals back to Earth, that straightforward feat helped to establish the foundation for contemporary communication satellites. The Hubble Space Telescope, which was introduced in 1990, revolutionized space exploration. Hubble had a perfect perspective of the universe and was able to take amazing pictures of galaxies, nebulas, and exploding stars instead of having to deal with Earth's filthy atmosphere. It had its share of issues as well. First blurry vision, then ongoing fixes. But after NASA rectified it, Hubble turned into one of astronomy's most useful instruments. The 2005 launched Mars Reconnaissance Orbiter looked toward the red planet, while Hubble concentrated on deep space. By taking high-resolution pictures of Mars, it assisted researchers in locating potential landing spots and searching for evidence of water. Mars became more and more like a destination that people may one day visit with each new image. Then there is the 1999 launch of the Chandra X-ray Observatory. Chandra did not observe visible light like other telescopes did. Rather, it saw strong X-rays from black holes, far-off galaxies, and dead stars. It revealed the universe to us in previously unimaginable ways, demonstrating that there is violent and vibrant activity even in the most remote regions of space. Back on Earth, people's navigation was subtly altered by the Global Positioning System, or GPS. This goes beyond being a space nerd. Pilots, drivers, and even those simply looking for a decent restaurant use GPS satellites. GPS, which was first developed by the U.S. military, is now a universal tool that helps people stay connected and on course wherever they are. It would be impossible to discuss space without bringing up the International Space Station, of course. This enormous floating laboratory was constructed in the late 1990s and has housed astronauts from all over the world conducting microgravity experiments that are impossible to conduct on Earth. It serves as a symbol of global cooperation, demonstrating that nations can cooperate to advance research even when they have different viewpoints. Music. Next up is SpaceX's Starlink project, which intends to encircle the Earth with a network of tiny satellites to deliver fast internet to any location on the planet. Although it's a game-changer, not everyone is pleased with it. Some astronomers worry that an excessive number of Starlink satellites could result in hazardous space debris, while others claim that the satellites degrade the night sky. It remains to be seen if this is a future catastrophe or a fantastic invention. Voyager 2's mission was much more ambitious. It was to travel farther and visit planets that had never been observed up close by a spacecraft. Voyager 2 was designed to surpass its twin, Voyager 1, in terms of pushing boundaries, traveling farther and seeing more when it was launched in the late summer of 1977. Voyager 2 took the slow path, in contrast to its twin, which rushed past Jupiter and Saturn before launching into deep space. This spacecraft was positioned to visit Uranus and Neptune, two planets that Voyager 1 never approached, in addition to Jupiter and Saturn. A unique planetary alignment enabled the spacecraft to slingshot from one globe to the next, using their gravity as a cosmic highway, enabling the entire voyage. Voyager 2 was prepared to make history after some astute modifications and enhancements. Voyager 2 was unique not only because of its destination, but also because of its design. The weak light surrounding Uranus, Neptune, and the ice giants required adjustments to its cameras. Researchers developed new techniques to stabilize those cameras over extended exposures, ensuring that the images were crisp and free of streaks of blur. Engineers developed more intelligent data compression techniques to make every bit of information matter when sending data back to Earth from billions of kilometers away. Since solar panels wouldn't function that far from the sun, the power supply presented still another significant obstacle. Rather, Voyager 2 was powered by nuclear, although even it had its limitations. NASA devised a rigorous timetable for operating the instruments, turning some off to conserve energy and extend the spacecraft's lifespan for decades. The largest planet in the solar system, Jupiter, was the first significant destination for the expedition. There, Voyager 2 captured breathtaking views of the Great Red Spot, tremendous lightning strikes, and whirling storms. It also saw Jupiter's moons up close, exposing ice-covered oceans on Europa, erupting volcanoes on Io, and other strange, unexpected environments. Next came Saturn, where the spacecraft had a close-up view of Titan, the planet's largest moon, and its intricate ring system. However, Voyager 2 continued on, aiming for the lesser-known planets at the solar system's boundary, in contrast to Voyager 1, which concentrated on Titan. Voyager 2 was the first and only spacecraft to sail past Uranus in early 1986. What it discovered was a delicate blue-green planet with almost no cloud formations, a planet that appeared uncannily smooth and featureless. However, there was more going on than first appeared. The planet's interior was probably organized differently than scientists had previously thought, as evidenced by the spacecraft's detection of an oddly skewed magnetic field. In addition, it found 2 faint rings that had never been seen before, and 10 new moons. Voyager 2's mission was a historic success just because of its flyby, but there was still one more visit to make. When Voyager 2 reached Neptune 3 years later, in the summer of 1989, it was discovered to be a planet significantly more active than Uranus. The spacecraft discovered the vast dark spot here, a huge storm the size of Earth whirling through the deep blue atmosphere of Neptune. With winds capable of tearing through anything in their path, Neptune's winds were the fastest in the solar system. Additionally, Voyager 2 discovered additional moons and verified that Neptune was surrounded by thin, clumpy rings. The most unexpected finding was probably that Neptune was producing more heat than it was getting from the sun, which indicated that energy was being stirred up deep within the planet. Voyager 2 continued after its grand tour was over. The spacecraft continued to send signals back to Earth as it drifted farther and farther away from the sun over the course of decades. It entered interstellar space in late 2018, after passing through the helipore, the invisible line where the sun's influence ceases. Officially, it was no longer in the solar system. Voyager 2 continued to tell us about the space outside our neighborhood, even though we were billions of kilometers away. Strange cosmic radiation bursts, pressure waves traveling through space, and signs of what's between the stars were all picked up by the probe. Voyager 2's survival was not simple. Power levels decreased over the years, forcing the mission team to make difficult decisions on what to shut down. NASA released a fresh software update in 2023 to keep the spacecraft from experiencing the same issues that beset Voyager 1. The thrusters, which are tiny rockets that keep Voyager 2's antenna pointed toward Earth, were also extended by engineers. The spacecraft could permanently lose contact if the antenna moves even a little. Is the discovery of Voyager 1 only an odd space glitch? Or have we at last discovered evidence of something we were never supposed to see? Please share your thoughts with us and don't forget to like and subscribe.
NASA making a historic announcement today that the Voyager probe has entered interstellar space, that place between the stars. It's now...
Since 1977, Voyager 1 has been exploring space, going beyond than anyone could have ever dreamed. This ancient spacecraft, which was first built to research Jupiter and Saturn, has already ventured into interstellar space and is still returning enigmatic data from uncharted territory. However, what is it actually like to be out there? Is space more dynamic and living than we think? Most importantly, did we step over a boundary that we weren't supposed to? Voyager 1's historic launch and primary objectives. Many people consider Voyager 1 to be one of the greatest feats of human deep space exploration. It was built for a spectacular tour of the outer planets, namely Jupiter and Saturn, and was launched on September 5, 1977. People did not realize at the time how far this little spacecraft would travel or how many decades it would continue to operate. Voyager 1 provides us with a look into the extreme regions of our solar system and beyond, and is now acknowledged as the furthest man-made object from Earth. NASA was eager to capitalize on a unique outer planet alignment that only happens once every 175 years in the 1970s. A spacecraft passing these planets could use gravitational assistance thanks to this alignment, burning a planet's gravitational pull to change course and increase speed without burning a lot of fuel is known as a gravity assist. An ambitious mission could use this method to visit several distant planets in a single journey. Participating in this mission profile were Voyager 1 and its twin, Voyager 2, which launched on August 20, 1977. The primary goal of the expedition was to explore Saturn and Jupiter. Their atmospheres, moons, rings, and surrounding space environment were all of interest to scientists. Prior to Voyager, telescopes, which aren't always able to see fine detail, were the main source of our knowledge about these far-off worlds. Everyone was shocked when the spacecraft passed Jupiter in 1979 and revealed active volcanoes on the moon Io. New information regarding Jupiter's weak ring system and swirling clouds in its atmosphere. Following Jupiter, Voyager 1 proceeded to Saturn in the early 1980s, revealing previously unobserved features and new moonlets, as well as our first up-close views of Saturn's intricate rings. Scientists decided to launch Voyager 1 beyond the orbits of Uranus and Neptune, and eventually beyond Pluto's path after it had accomplished these important mission tasks. Voyager 1 was powered by a radioisotope thermoelectric generator, or RTG, which allowed it to continue transmitting data. Instruments were eventually switched off to save power, yet there was still enough capability to continue taking useful measurements. The spacecraft outlasted many projections, sending data long after its original mission concluded, despite mission designers' expectations that its power and systems might only endure until the late 1980s or early 1990s. NASA's Jet Propulsion Laboratory, or JPL, in Pasadena, California, provided expert direction and meticulous engineering, which contributed to this achievement. These spacecraft have evolved into long-term research instruments for comprehending the heliosphere and interstellar space, yet engineers still frequently view them as time capsules containing the golden record for future discoverers. Voyager 1 is still sending signals that help scientists better grasp the boundary between our solar system and the deep unknown, despite the fact that several of its equipment are no longer in use. A chaotic area of charged particles and cosmic rays is produced at this boundary when the solar wind and the interstellar medium encounter. The protective function of the heliosphere. The heliosphere is one of the most crucial ideas when discussing Voyager 1. To put it simply, the solar wind dominates the heliosphere, which is a bubble-like region of space, a constant influx of charged particles from the sun, mostly protons and electrons. This bubble serves as a kind of protection against specific kinds of cosmic radiation and stretches well beyond the orbit of the outer planets. Particle flows, magnetic fields, and local space weather are all shaped by the sun's powerful effect inside this bubble. The heliosheath, the termination shock, and the heliosphere itself are important regions. The solar wind suddenly slows down during the termination shock when it starts to crash with the interstellar medium, which is the region outside our solar system that is packed with gas, dust, and cosmic rays. The spacecraft enters the heliosheath, a turbulent region where the solar wind is slower and more chaotic after overcoming the termination shock. Last but not least is the helipore, which is frequently regarded as the heliosphere's outer border or boundary, where the forces of interstellar space and the solar wind are roughly balanced. Many individuals believed that these borders were smooth, or at least predictable prior to Voyager 1. A straightforward passage from the solar wind zone to the interstellar region was proposed by a number of models. Voyager 1 and Voyager 2 data, however, showed that these regions are more messier. Cosmic rays can enter the heliosphere through unexpected turbulence and hole punch zones created by interactions with interstellar magnetic fields and plasma. The area close to the helipore may occasionally be further disturbed by solar events such as coronal mass ejections that radiate outward. Protecting Earth against galactic cosmic rays, which are charged particles that travel across galaxies at almost the speed of light, is another function of the heliosphere. Both spacecraft electronics and astronauts may be at risk from these cosmic rays. Scientists can more accurately forecast when cosmic rays will be more or less intense by examining how the heliosphere evolves over time. For instance, the stronger solar wind can assist protect the solar system from some cosmic rays during times of high solar activity. Deeper penetration of high-energy cosmic rays may occur during times of low solar activity. Voyager 1 has traversed these areas for decades, collecting data that was previously unavailable to mankind. Its data assisted in confirming that the termination shock could fluctuate based on the sun's activity and other circumstances rather than being positioned at a set distance from the solar. Additionally, it demonstrated that the heliosheath was more intricate than previously believed, containing a mixture of magnetic fields, heated plasma, and whirling flows coming from many directions. A genuine spacecraft was suddenly prodding this area, which had previously only been anticipated theoretically, and sending back signals. Knowing the heliosphere entails knowing not just the environment of our own solar system, but also that of other Milky Way stars. A heliosphere powered by stellar winds is probably present in many stars. Scientists can make educated guesses about the behavior of the border areas surrounding other stars by closely examining ours. Because the amount of cosmic radiation a planet receives can affect whether life could exist on its surface, this has broad implications for research on exoplanets as well. Thus, Voyager 1's investigation of the outer reaches of the heliosphere contributes to more general inquiries concerning habitability and extraterrestrial life. Going across interstellar space. Voyager 1 made headlines on August 25, 2012, when it formally entered interstellar space by passing what scientists refer to as the helop. Following a thorough analysis of particle count data, magnetic field measurements, and abrupt decreases in heliospheric particle concentrations, scientists made this revelation. It was more complicated than just crossing a line on a map. Rather, it included a detailed examination of the changes in magnetic field orientations and cosmic ray intensities around the spacecraft. By measuring the local electron density, scientists can verify an interstellar crossing. Compared to the heliosphere, interstellar space has a higher electron density. Therefore, a sharp increase in electron density detected by Voyager 1 indicated that the spacecraft had entered a new environment. The way cosmic rays from beyond the solar system behaved was another hint. Cosmic rays are slowed or partially deflected inside the heliosphere. Thus, the increase in cosmic ray counts suggested that Voyager 1 had left the protective bubble of the Sun. The road is far from over, though, even after reaching that milestone. The barrier may not be an all-or-nothing occurrence, according to others. Alternatively, the spacecraft might go via filaments or fingers where heliospheric plasma and interstellar particles mix, allowing for a slow back-and-forth crossing. Different lines of evidence, variations in plasma wave oscillations, changes in the direction of the magnetic field, and variations in charged particles are all part of the controversy around the exact moment Voyager 1 departed the heliosphere. However, there is ultimately agreement that the spacecraft is in fact in interstellar space, which indicates that it has left the primary area of the Sun's impact. Voyager 1 has not completely escaped the gravitational pull of the Sun, even though it is in interstellar space. To be totally free of our star would actually require a far greater distance. But crossing the helop is a first from the standpoint of space physics. It implies that researchers may now directly examine the local interstellar medium, which is the gas and dust-based substance that exists between stars and has the potential to create new stars and planetary systems in the future. One surprising finding is that as Voyager 1 entered interstellar space, the direction of the magnetic field around it didn't shift as sharply as anticipated. This implies that the border region is more permeable than expected, or that the lines of the magnetic field from the energetic field from the Sun may be somehow aligned with the interstellar magnetic field. Data from Voyager 1 has demonstrated that a complete switch to an external field is not always required when entering interstellar space. Rather, the field of the Sun may be stretched or curved around the area Voyager 1 is traversing. Additionally, Voyager 1 captured what are called tsunami waves, shock waves that the spacecraft can detect as coronal mass ejections from the Sun travel outward and strike the interstellar plasma. These occurrences demonstrate how our star still influences local conditions, even outside the heliosphere. According to some scientists, the helipore is a leaky boundary that allows fields, plasma, and energy to continue interacting. Our understanding of this outer region becomes more complex as more evidence becomes available. It turns out that the spacecraft is not totally isolated from the Sun's impact just because it is in interstellar space. Rather, it is an area where the extended solar environment and the local galactic environment interact. NASA's communication and deep space network issues. We must examine NASA's Deep Space Network, DSN, to comprehend how we communicate with Voyager 1. The DSN is a global network of massive antennas dispersed over 3 key sites: Tidbilla near Canberra, Australia, Robo de Chavela near Madrid, Spain, and Goldstone in California, USA. Because at least one station can observe a specific spacecraft anywhere, it may be in the sky. This spacing enables continuous coverage of spacecraft regardless of which way Earth is turning. There are several different sized dishes in each antenna complex. The largest ones have a diameter of up to 70 meters, which aids in capturing the weak signals from distant probes such as Voyager 1. By the time Voyager 1 signals reach Earth, they are quite feeble. The signal strength can actually be much lower than a whisper. Sensitive electronics are used by the DSN to identify and decode these signals, turning them into ones and zeros that may be transformed into visuals and scientific data. The lengthy communication lag is one of the main obstacles. At distances of more than 150 astronomical units, it can take more than 20 hours for a signal to travel one way, even though Voyager 1's radio waves travel at the speed of light. As a result, two-way communication can easily surpass 40 hours. Scientists and engineers must therefore exercise patience. The spacecraft cannot be joysticked in real time. Rather, they have to plan commands far in advance and then watch to see if the probe reacts as they anticipate. It's also important to note that Voyager 1 systems are getting older. The spacecraft uses plutonium-238 fueled RTGs, and each year its total power output significantly declines. NASA must therefore carefully consider which instruments will continue to run. Additionally, problems may arise in subsystems like the attitude control system, which controls the spacecraft's orientation, or the flight data system. Sending orders, waiting for responses, and troubleshooting issues can take months when anything breaks. Additionally, NASA has to divide up DSN time across numerous projects. The DSN supports dozens of ongoing projects, such as probes investigating the Sun, satellites orbiting other planets, and rovers on Mars. Priorities must be balanced when scheduling to ensure that each mission has adequate antenna time. Even though Voyager 1 is no longer a main mission for planetary encounters, it still needs assistance in order to gather and send data on the interstellar medium. Operators may shuffle DSN time in order to get in touch right away if an issue occurs. All things considered, the DSN is essential to practically every deep space mission the agency does, not just Voyager 1. It is an essential component of the system that enables humans to communicate with the solar system's outermost regions and beyond, with multinational partners working together to keep our space missions on course. It also demonstrates the global aspect of space exploration, abnormalities and bugs in the data system. Minor issues can escalate into serious issues since Voyager 1 is beyond repair. Every issue, from sensor failures to stored memory problems, has the potential to impede or complicate data flow. Engineers discovered that Voyager 1 began transmitting jumbled data from its flight data system in the middle to end of 2024. It was initially difficult to diagnose because the cause might have been anything from a hardware malfunction brought on by decades of cosmic ray exposure to a straightforward software glitch. After months of trial and error, careful analysis of fragmentary data, and directives transmitted through the DSN, NASA eventually regained some degree of control. As soon as the data started to make sense, they recognized that the spacecraft's surroundings had altered. The measurements indicated that the outer edge of our solar system was experiencing greater turbulence than anticipated. Certain signals suggested that Voyager 1 might be subject to unknown forces or local disruptions, and the plasma environment appeared to be oscillating. The Plasma Wave System, PWS, which can identify oscillations in the charged particle environment, is a crucial tool for comprehending these anomalies. Scientists can determine particle density and activity by listening to plasma waves. For example, when the spacecraft meets shock waves from solar outbursts or crosses particular boundaries, the device can detect spikes in electron density. Restoring these signals was of utmost importance because the flight data issue threatened to obscure them. Additionally, the magnetometer's mag values are quite important. They monitor the strength and direction of the local magnetic field. A large-scale routing of magnetic field lines is one example of an unusual phenomenon that the magnetometer may observe. The data from Voyager 1 in late 2024 and early 2025 appeared to point to sudden changes, suggesting that the environment was not the quiet area that many models had projected. Rather, it resembled a whirling transition zone with abruptly moving pockets of charged particles. Detectors of cosmic rays also monitored high-energy particles from beyond the solar system. If the spacecraft is traveling through areas where magnetic fields are blocking or funneling charged particles, it can be determined by abrupt reductions or spikes in the cosmic ray count. Interpreting these findings was initially challenging due to the irregularities in the data. It was unclear whether the alterations were due to the spacecraft's instruments malfunctioning or a genuine change in the surroundings. Following the partial restoration of the flight data system, engineers were able to verify that the region was dynamic by comparing signals from other systems. The enigmatic signal at low frequencies A consistent low-frequency hum at about 3 kHz is one of the most peculiar discoveries linked to Voyager 1 in recent years. This hum is located below the usual frequencies of plasma waves. The signal was initially written off as background noise, but as Voyager 1 advanced deeper into interstellar space, it became more apparent. There are various theories among scientists as to the origin of a 3 kHz tone. One explanation is that the spacecraft surrounding plasma has a natural resonance. An alternative theory is that the signal is generated by charged particles orbiting the Sun along magnetic field lines, but the regularity of this hum is what makes it so unusually fascinating. Variations in density or spikes in solar activity can cause changes in plasma frequency. However, despite varying solar circumstances, this hum has remained remarkably constant. While the mainstream scientific community tends to favor natural explanations wherever possible, others have conjectured about non-natural beginnings. Without additional information, it is challenging to completely rule out the possibility that the signal is a planned transmission, even though there is no obvious evidence of an alien culture. The hum appears more like a continuous wave that originates from cosmic medium interactions. This hum's existence also connects to the more general subject of electron density and plasma waves. Following significant solar outbursts, Voyager 1 has captured plasma oscillations at higher frequencies. However, there appears to be less variation in the 3 kHz tone. It does not increase or decrease in time with significant changes in space weather. This consistency could indicate that the signal is an interstellar medium drone. It could be a vibration caused by the interstellar magnetic field, background plasma, and cosmic rays interacting on a massive scale. According to several scholarly articles, this kind of steady wave could aid in more accurate measurements of local circumstances. The wave's frequency may serve as a baseline indicator of the density of the medium around Voyager 1 if it is correlated with the local plasma density. We may be able to compare signals in various near-interstellar space areas with the aid of future spacecraft or even the data from Voyager 2. It may be confirmed that hums are a common natural phenomenon if both spacecraft detect them at identical frequencies. A sustained low-frequency transmission could travel great distances since radio waves are good at traveling through space's vacuum. It might exist in numerous star systems if it is a universal background wave. It's interesting to consider whether sophisticated civilizations could recognize shifts in such basic patterns as a warning indication that something is approaching their borders. Even if that is highly conjectural, it emphasizes how any persistent, unexplained signal in space stimulates original thought on a variety of levels. The unfathomable powers and the pull of gravity. The Sun, planets, dwarf planets, and big asteroids are among the known celestial bodies that are used to determine Voyager 1's official trajectory. There have been indications, nevertheless, that its course slightly departs from forecasts. Generally speaking, thermal phenomena, such heat from the spacecraft's RTG producing a modest propulsion, can account for these minor variances. Similar anomalies were seen by Pioneer 10 and Pioneer 11 previous probes, which were hotly contested before providing some partial natural answers. However, recent evidence points to an external pull that the known masses surrounding Voyager 1 cannot account for. Scientists have thought about dark matter clumps or rogue planets as potential culprits that may move through the galaxy without being seen. Another theory is that there might be a dense object or a tiny black hole out there, but the chances are slim. Astronomers search for gravitational lensing effects or minute variations in star positions to validate such a suspicion. However, there is currently no compelling evidence that Voyager 1 is being pulled by a compact, huge object. Some people also attribute unexplained gravitational behavior to dark matter. Although it is believed to comprise the majority of the universe's mass, it does not normally interact with light. There might be a slight gravitational pull if there was a dark matter cloud. However, according to the majority of dark matter models, it is dispersed somewhat uniformly throughout the galactic scale rather than in large, distinct clusters that would drag a spaceship down. Furthermore, other astronomical observations would have probably revealed local inhomogeneities on dark matter. What is causing the little drift, then? It's probably still a minor influence of the heat from the spacecraft or tiny thruster firing misalignments. The narrative is still intriguing, though, because it serves as a reminder that we do not yet fully comprehend all of the variables that could affect an object in deep space. Small alterations can even be brought about by electromagnetic forces. The spacecraft may experience difficult-to-detect momentum gains or losses if it picks up tiny electric charges or passes through an unanticipated plasma area. The official trajectory is still broadly in line with projections, according to most scientists, notwithstanding the enthusiasm around invisible forces. The challenge of measuring an object so far away limits the margin of error. The signals are quite weak, and each set of data must be carefully analyzed. Small inaccuracies could accumulate over time when the DSN tracks the craft's velocity using Doppler shifting techniques. Therefore, even though gravitational anomalies make for interesting headlines, the most straightforward explanation is typically that the spacecraft or minor measurement errors are to blame. Rumors of secrecy have frequently accompanied space travel due to both public curiosity and government concealment. Some people believe that information may be kept secret for security concerns whenever interesting data surfaces. The majority of NASA's scientific data is actually publicly available. Raw photos and instrument readings from missions such as Voyager, Cassini, and the Mars rovers are available for download from some archives. It is true, nevertheless, that not all data is immediately made available to the public. Although there are real precedents for increased secrecy in space research, NASA may withhold some conclusions until they are confirmed or until scientists have had time to write official articles. Some early flights, for instance, served both military and scientific purposes during the Cold War. As a result, the data release was occasionally incomplete. Coordination with government agencies is still possible in the current era if a discovery includes new technology or may have national security ramifications. Heavy secrecy is unlikely to be at work for Voyager 1, which is located far from Earth and not close enough to any planet to disclose new strategic details. It's more likely that NASA is hesitant to release data that is unclear or insufficient when an instrument malfunction occurs. However, the uncertainty might pique people's interest. The slow release of official pronouncements or the appearance of sensitive material can lead to speculation about secret signals or alien contact. Some believed that NASA had concealed evidence of a massive body hiding beyond the helop or of a manufactured signal with Voyager 1. However, scientists consistently offer more believable, everyday explanations. The scientific community provides input as new data is analyzed in peer-reviewed publications. The notion that space might not be empty frequently interacts with the public's curiosity with possible cosmic watchers or edges that fight back. Because it encourages greater interest in astronomy and astrophysics, the curiosity is beneficial. Although some of the conjecture may be exaggerated, it highlights how people inherently question whether we are alone in the universe or whether there is another being in our immediate vicinity. The wider cosmic landscape and its unexpected aspects. The Milky Way galaxy is full of gas, dust, radiation, and innumerable stars, all of which must be understood in order to fully appreciate the discoveries made by Voyager 1. There is more to interstellar space than nothing. In addition to evidence of heavier elements, it has an extremely low density of hydrogen and helium. The distribution of magnetic fields and plasma can produce large-scale structures that we are just now mapping, and temperatures can fluctuate greatly. The galaxy may be shaken by supernova shock waves, which compress gas pockets into denser clouds that may eventually develop into star nurseries. This is also where the idea of cosmic rays fits in. These are high-energy particles from black hole accretion disks, pulsars, exploding stars, and other energetic settings that move close to the speed of light. Fewer of these rays enter the heliosphere because the sun pushes back against some of them through the solar wind. The boundary zone is important to scientists because of this. What cosmic radiation enters through our cosmic front door is filtered. Even though Voyager 1's instruments were created decades ago, they are still able to identify intriguing phenomena, including abrupt increases in the number of cosmic rays, variations in the density of local plasma, and changes in the magnetic field. Extreme solar outbursts have the potential to produce shock waves that eventually reach the spacecraft after radiating outward for months or years. We can learn how far the sun's reach extends and how cosmic weather can affect a boundary region long after the solar event has passed at Earth by seeing how these waves interact with the interstellar environment. The implications of this for prospective future cloud objects are likewise attracting increasing attention. Up to 100,000 astronomical units from the Sun, the Oort cloud is a fictitious shell made up of frozen comets that surrounds our solar system. If it can escape at all, Voyager 1 won't be able to do so anytime soon because it is still far inside that area. We may be able to predict how comets in the outer solar system are prodded into new orbits, occasionally causing them to move toward the inner solar system by learning about the surrounding environment. In addition, astronomers can improve their star formation models by researching the interstellar medium. Interstellar gas clouds undergo a variety of chemical reactions. The formation, disintegration, and reconstruction of molecules creates the conditions for the eventual ignition of new stars. Scientists can gain an understanding of the processes that may be occurring throughout the galaxy by tasting a tiny sample of the medium at the frontier of our solar system. Thanks for watching another episode. Please like and subscribe for similar content.
After more than 40 years of silently navigating the vast blackness of interstellar space, Voyager, humanity's furthest spacecraft, has suddenly detected something extraordinary. Researchers have verified that Voyager detected a signal with an enigmatic pattern embedded in cosmic radiation. This noise isn't merely random. It contains universal constants like pi and mathematical sequences like prime numbers. We might no longer be alone in the universe, as these exact patterns imply an intelligent origin. The unexpected contact from Voyager casts doubt on our preconceived notions about communication beyond Earth and raises the possibility that a highly developed civilization is attempting to communicate with us across the stars. This discovery marks a new chapter in our cosmic journey after years of searching. A whisper from the unknown that has the power to permanently alter our perception of who we are and where we fit in the universe. The silent messenger of humanity in the cosmic sea. Voyager 1 and Voyager 2, two remarkable spacecraft launched by humanity in the late summer of 1997, signaled the beginning of our first real deep space ambassadors. In addition to being scientific tools for researching the outer planets, these probes were intended to serve as time capsules that would convey information about Earth and humanity in general. These capsules, sometimes referred to as the Golden Record, contain whale sounds, multilingual human greetings, international music, and photographs that document the variety of life on Earth. In an effort to reach out across space and establish a connection with any sentient being that might be interested, Voyager was a daring declaration of curiosity and hope. After their first encounters with planets, Voyager 1 and Voyager 2's journeys rapidly diverged. After its encounter with Saturn, Voyager 1 became the first man-made object to enter interstellar space by taking a quicker route out of the solar system. A more daring path was followed by Voyager 2, which became the only spacecraft to visit Uranus and Neptune before venturing into interstellar space years later. Together, they have journeyed more than 14 billion miles, surpassing all previous missions' distances while silently navigating the cosmic ocean. However, Voyager is more than just damaged spacecraft. It represents the persistent human desire to discover, to go beyond the known, and to make a difference in the cosmos. These spacecraft transport humanity's dreams, tales, and very being into the unending blackness, a representation of our common desire to learn and connect. They convey a lot about our desire to comprehend the universe and our place in it, even though they drift silently. Voyager changed our knowledge of the Guam and ice giants that reside in the outer reaches of the solar system by discovering incredible new worlds as it traveled past the inner reaches. The planetary discoveries of Voyager, our understanding of the giant planets Jupiter, Saturn, Uranus, and Neptune was completely transformed by Voyager's planetary flybys. Each unveils worlds full of vibrant and unexpected details. The Great Red Spot, a storm bigger than Earth that has raged for centuries, is one of the raging storms that Voyager revealed to be present on Jupiter. Scientists were taken aback by the spacecraft's discovery of active volcanoes on Io, one of Jupiter's moons, which demonstrated volcanic activity far from Earth. The enormous and potent magnetic field of Jupiter, which dwarfs Earth's and influences the surrounding environment, was also charted by Voyager. The Voyager probes travel to Saturn after Jupiter, revealing the planet's many moons and the exquisite beauty of its rings. The information broadened our knowledge of what planetary systems can look like, from the glistening icy particles in the rings to the intriguing geology of moons like Titan and Enceladus. Due to its unusual course, Voyager 2 visited Uranus and Neptune, two planets that were still unknown prior to these missions, in addition to Saturn. While Neptune displayed the Great Dark Spot, a storm similar to Jupiter's but less permanent, Voyager found an odd sideways rotation at Uranus that was unlike any other planet. These discoveries cast doubt on long-held beliefs and raise fresh queries regarding the origins and development of planets. The science of the solar system was drastically altered by Voyager's discoveries. It demonstrated that planets are dynamic entities rather than immobile balls of Bohr ice. These experiences proved that exploration always brings surprises, expanding our knowledge and laying the groundwork for subsequent missions. After exploring the outer planets, Voyager proceeded to explore new areas outside of the Sun's protective sphere. Interstellar space is reached by Voyager. The heliosphere, a huge bubble of charged particles and magnetic fields blasted outward by the solar wind, marks the separation between our solar system and the rest of the galaxy. The planets are protected from the full force of cosmic radiation by this bubble. Voyager 1 was the first probe to cross this protective bubble, despite years of speculation by scientists about its boundaries. Voyager 1 became the first artificial object to enter interstellar space in 2012 when it passed through the heliosphere's outermost region, known as the helipause. Changes in particle measurements confirmed this historic event: an abrupt decrease in solar wind particles and a rise in extrasolar cosmic rays. Voyager 2 followed 6 years later with its still operational plasma sensors, validating the previous findings and offering fresh perspectives on the nature of this boundary. Because it requires detecting minute changes in particle density and magnetic fields in a vast empty space, measuring the helipause is extremely difficult. According to Voyager's observations, interstellar space is teeming with cosmic rays, magnetic fields, and plasma rather than being empty. This area is not the peaceful void that was once thought of. Rather, it is dynamic and turbulent. These discoveries reshape our knowledge of our solar neighborhood in relation to the environment that the Sun and planets pass through. Our connection to the cosmos is strengthened as Voyager continues to return data from billions of miles away, providing an unparalleled look into the makeup of the interstellar medium. Voyager has revealed a surprisingly active environment beyond this boundary, changing our understanding of the universe and raising issues that scientists are still fascinated by. This is what Voyager sees when it crosses into interstellar space. Voyager stepped into a world that was very different from what we know on Earth. High-energy cosmic rays from far-off supernovas and galaxies, ubiquitous magnetic fields, and a tenuous mixture of charged particles known as plasma fill the interstellar medium, or the space between stars. This environment is far from empty, as demonstrated by Voyager's instruments. Rather, it is a complex, dynamic area that is teeming with subtle activity. The plasma density outside the helipause was much higher than inside the solar bubble, according to data from Voyager's plasma detectors. Stronger and more turbulent magnetic lines were observed threading through this medium in magnetic field measurements. In contrast to previous theories of a peaceful, empty void, this turbulence reveals a restless cosmic neighborhood with variations in currents driven by galactic forces. The existence of interstellar weather and changes in magnetic fields and plasma density over time were among the most unexpected discoveries. These modifications imply that strong processes that are far removed from the Sun's influence, such as shock waves from stellar explosions and interactions with the galactic magnetic field, shape the space Voyager travels through. This exercise aids in our comprehension of the interactions between the Sun's protective bubble and the massive galaxy that surrounds it. Even though Voyager is billions of miles away from Earth, it still sends data every day that helps us learn more about the universe. In the shield that surrounds our solar system, every measurement aids scientists in improving models of interstellar space. Humanity's perspective on the cosmos is expanded by Voyager's ongoing mission, which depicts a universe that is more dynamic and interconnected than previously thought. As Voyager traverses this dynamic interstellar medium, researchers started to notice something even more surprising. Within the cosmic din, there was a whisper of mystery and intelligence. Voyager detected an intelligent whisper. Amidst the immense cosmic radiation that Voyager was picking up, scientists noticed something out of the ordinary. A signal buried in the background noise, faint but clear. This signal showed an ordered pattern, in contrast to the random burst that characterizes cosmic phenomena. It included prime numbers from the Fibonacci sequence, which are renowned for their special mathematical characteristics, as well as other mathematical sequences that appeared too exact to be natural. More interestingly, the signal included encoded constants like pi and Planck's constant, which are basic numbers that could be used as a universal language by any highly developed civilization with scientific knowledge. Scientists and SETI researchers were excited about the possibility of intentional communication, as these constants might be part of a cosmic message. This signal was detected by Voyager's instruments during routine measurements, and it was promptly confirmed by observatories on Earth that it was not a result of the spacecraft's systems. This finding revealed that even in data we believe to be well understood, unexpected patterns might be hiding, which ushered in a new era in our hunt for extraterrestrial intelligence. The existence of such a mathematically rich signal suggests that we may not be alone in the universe, although scientists are still cautious. This signal casts doubt on our comprehension of cosmic phenomena and raises the possibility that highly developed civilizations are subtly using mathematically universal methods to communicate with one another across the void. In addition to sophisticated technology, deciphering this cosmic message calls for a fresh perspective on how sentient entities could interact over interstellar distances. Traditional searches for extraterrestrial intelligence frequently concentrate on radio waves or optical signals to determine how advanced civilizations might communicate. Voyager's discovery of this peculiar signal, however, suggests that more developed societies may employ more nuanced, complex means of communication. Techniques that use quantum effects or natural cosmic radiation modulation to encode data. Using patterns like prime numbers or fundamental constants as a communication base, mathematics and physics combine to create a universal language that is understood by people of all biological backgrounds. It guarantees that any listener with a high level of scientific knowledge will be able to identify the message as both meaningful and artificial. This profile is met by the signal Voyager picked up, indicating a deliberate attempt to get past linguistic or cultural obstacles. Interstellar communication is fraught with difficulties. Signals deteriorate over long distances, and messages can be readily obscured by cosmic noise. Signal distortion is inevitable, and timing delays can last for years. Any civilization that wants to communicate must thus employ extremely effective and durable techniques, perhaps using modulated cosmic rays or quantum entanglement to convey their messages. SETI programs are urged by this discovery to expand their search strategies by analyzing data on quantum signals and patterns of cosmic radiation. Future missions might use sensors made especially to pick up these minute changes, leading to new discoveries in our never-ending search for the answer to the age-old question, are we alone? The ramifications of humanity's struggle with this possible cosmic contact go far beyond science and profoundly affect our identity and position in the cosmos. Humanity is no longer alone. Centuries of human thought are challenged by the prospect of receiving a message from a highly developed extraterrestrial civilization. It appends the long-held notion that humans are alone in the universe and raises important issues regarding our identity and place in the cosmos. If there are others, how far away are they? What shape do they adopt? And above all, what do they wish to convey? The philosophical, religious, and existential frameworks that have influenced human culture must be reconsidered in light of these issues, which touch on identity, purpose, and destiny. This cosmic contact represents a thread connecting civilizations separated by light years, a connection spanning unthinkable distances. It encourages us to see ourselves as a part of a greater cosmic community and ushers in a new era of harmony, humility, and hope. These themes have long been explored in popular culture, ranging from science fiction movies to books. However, actual scientific evidence now takes these queries from fantasy to critical consideration. There are ethical issues. What are we to do? How can we responsibly disseminate this knowledge? Voyager's signal is more than just data. Humanity's yearning to fit in, comprehend, and transcend ourselves is reflected in it. The public and scientific community must strike a balance between excitement and critical thinking as the excitement grows. The technical difficulties and achievements of Voyager. The 40-year voyage of Voyager is a tale of engineering, wonder, and tenacity in addition to discovery. These spacecraft, which were designed in the 1970s using technology that now seems antiquated, have defied expectations by continuing to function billions of miles away from Earth. The issue of power is never-ending. Each year, Voyager's radioisotope thermoelectric generators, RTGs, produce less energy due to a gradual decline in efficiency. However, crucial instruments have remained online thanks to clever engineering and cautious management, enabling the probes to carry out their mission well beyond their initial lifespans. There are many difficulties in communicating over the vast distance, currently more than 23 billion kilometers. One-way signals take more than 20 hours to reach Earth, and by then, they have weakened to almost undetectable levels. As evidence of human technological prowess, NASA's Deep Space Network uses some of the most sensitive antennas in the world to stay in touch. Recent technical problems, like electronic aphasia that affects Voyager's memory units, have put mission engineers' ingenuity to the test through meticulous adjustments and software patches. As an example of humanity's resolve to protect this priceless connection to the stars, they have managed to keep the spacecraft in operation. Voyager represents human ingenuity, curiosity, and optimism, evidence that we can reach the very edge of our cosmic neighborhood if we are persistent and creative. Even though Voyager's legacy is safe, the discoveries it made possible spur new endeavors and aspirations for space exploration and possibly even interstellar communication. The discovery of this mysterious signal by Voyager ushers in an exciting new era for humanity. It serves as a reminder that the cosmos is big, enigmatic, and perhaps full of other sentient beings who are ready to communicate. The discovery inspires us to embrace new ideas and cutting-edge technologies in order to expand our understanding of communication, even as scientists proceed cautiously. Once a silent messenger bearing the tale of Earth, Voyager now returns with a message, an echo from the depths of space that calls into question our isolation. Curiosity, humility, and a strong sense of connection are sparked by this interaction. Voyager's whisper serves as a reminder that the universe is full of mysteries and that our search for them is only getting started as we get ready for more complex searches and future missions. The cosmos is communicating. Are we prepared to hear?